Okay, what I have here, this is a Wavecom. This is an Agile modulator. It's a professional Agile modulator. I've got a couple of these things that I've been using over the years. And this one went dead a while back. This was a channel, this one's set to channel 7. I have another one identical to this that is still working that is set to channel 5. And I also have a couple of Olsen technology, which one of them is now set to channel 11. I used to have it on our channel 7. I used to have it on channel 11. I used to have, I had my, when I was using my off-air cable boxes and had them feeding throughout the house on the house cable, I had my media player that plays my stereo music stuff on channel 4 MTS. I had off-air boxes on Wavecom on channel 5, and I went on channel 7. Had my security cameras on 11, or 9 I should say, and had one of my cable boxes for my cable TV that feeds throughout the house. I had it on channel 11. I had a few other modulators as well, but say this one packed it in a while back, and I think maybe we'll take a look at this and see whether I can get this thing to work. Now what happened on it is the AC adapter failed, and it got fed AC instead of 12 volts DC. The rectifier shorted on it and it was getting AC. So let's cook something in here. The adapter is now a new one, it's fixed. As you can see, when I plug it in, I have no indication that we've got any RF power. And we don't have any RF power. So I'm going to take this thing apart and just see whether I can figure out what is wrong with the thing. This was actually made in Canada, this unit. Designed and manufactured by Wavecom Electronics, Canada. 306, that would put it in Saskatchewan. So this is actually a Canadian product. Very good quality, but something has gone wrong with it, and that's what we're going to try and figure out in this video. Now, I've never worked on one of these things before. I have no idea about any of the circuitry on here, and I doubt very much whether I'm going to find any data on it. So if you're seeing this video, obviously I've got it going. Otherwise, I probably won't show you the video. But let's just take a look. Even if I can't get it working, maybe I will show it. We'll figure that out when we get there. But I've got the cover off it now. I'm going to pull the board out and we'll take a look at what's going on this thing and see whether I can make any sense of how this thing is laid out. So basically what we've got here, these are the SAW filters. This is a SAW filter modulator. It's the type that a cable head end could also use to insert multiple carriers. So what's underneath here is just the tuned circuitry. I'm going to check some voltages on this thing. This fancy work that you see over here is just that originally these units had just F81 connectors for the audio and video, and I wanted RCA plugs to plug it into consumer equipment. So I ripped off the original F81 connectors that were used for the audio and video inputs and just attached some regular RCA plugs. That's all that is. But that was fine. I say this thing I've had for probably 10 years. This modulator is one of the first ones that I set up here. So I think first things first, I'm just going to go through with a meter and see if we have all of our voltages that the unit is expecting. I actually just found out that this thing actually is generating a signal. So we're not totally dead, but we have no power because that cable is directly connected to the TV. I'm not trying to put it over the air or anything. I've just got it going right to the television, and as you can see, the picture is very noisy. So we have a problem with the output stage on this thing, which makes it a little bit easier, I guess, because at least we know that something's working here. My DVD is going to start to play. So let's see if we can find out where the power output on this thing is set. and where the amplifier is. So I'm just probing around with my meter here, checking some voltages, and I've got nothing down here on some of these coils and some of these capacitors. I got nothing. I'm just going to measure some voltages around here. Nothing. Like, I got no voltages. If I show you the meter here, I got nothing. No voltages on anything in here. It's just so weird. Make sure you can see the meter. What's going on here? Nothing. Nothing. Oh, 8 volts. What the hell? Okay. It's weird. I had nothing there a minute ago. Now I got power. Now I got 5 volts over here. Oh shoot, the light's on. It's working. The unit's working now. Holy smoke. So the only thing I did was I was pushing my probe through here, measuring some voltages. I bet you we got a bad solder connection. One of these transistors in here must have, or one of these resistors. I was just measuring some of these voltages here, and I had voltage on one side but nothing on the other, and then all of a sudden I push the probe down a little more and I get voltage, and now I notice that my green light on the front here is on, telling me I've got RF. Now I've got voltage on my transistors, right? These transistors all had no voltage on them before. Where are we here? We got 5 volts here now. We had 0 volts before, right? And over here, I got my 5 volts back here, and my amplifier is now working. I'm going to heat up my soldering iron and just go over these connections here. It looks like that might be where the problem is, was just the solder connection's gone bad. I had another one of these things I tossed too, I think. I'm pretty sure I had another one of these units that I tossed because it was dead. It was one that was given to me that was dead, and the hell. Okay, well, let's get this thing heated up, and I'm going to resolder these transistors here where I was, and the chip resistors where I was probing around. It looks like I found the problem with this thing. So I'm just going to solder the area that I was probing with the meter when it started working, because I think this is where the problem is right in here. My biggest pet peeve to these chip components now is that they're getting very difficult to see. "20 years ago I wouldn't have had problems seeing these things, but today it's becoming much more of a challenge to see a lot of these real fine connections. And this magnifier I'm using is not the best. It's not the strongest. I'm going to need a bigger magnifying glass, because this one I've got here is just a little cheap one, and I mean, it gets the job done, but it certainly could use a bit stronger one at times. And working on chip components is one of those times. So I'm just going to reheat all the connections that I was probing around when this thing started working. There were the ones. I'll plug the power back in and see whether it comes back on. Yep, it's working. I was How's my RF level control work? Even down at minimum, it's got a perfect picture. Check this out. Looks like I fixed another one. Yay. Let me just get this thing back together. So to recap, yeah, we're going to recap this thing, right? No. To recap the problem, this is where I was measuring. I was measuring these transistors down here, and I had voltage on one side of the transistor, and I had nothing on the other side. And then when I just happened to push the probe down here a little bit more, and all of a sudden I got voltage that came up. And when that voltage came up, I noticed that the green RF on light had come on, and I looked over at the screen, and well, the snowy picture that I had seen before was now crystal clear. So I just went through and I just resoldered just these two transistors and the resistors that are in this area here, because now my 5 volts came on. I had no power. I had no 5 volts over to my RF amplifier ICs over here. These are little ICs that they use for the power amplification, and I had no 5 volt supply. I had no 5 volts here on the resistor here going in, and nothing, no power on them. So the modulator was working, but the RF amplifiers weren't. And it looks like it was just a bad connection on one of these regulators or switching transistors that caused the problem, because the unit's working great now. So we fixed another one, saved another one from the scrap heap. I'm just going to put this thing back together, and we'll find a use for it. I have to tune it to a different frequency though, because I've set another one up on channel 7. And I have a channel 5, I have a channel 4, channel 5, a channel 7, 9, 12. But the neat thing about these modulators is this can go anywhere from channel 2 all the way up to channel 99. So it'll even go on the band that occupies where the FM radio frequencies used to be, which is 95 to 99. This can go on any CATV channel. That's what all these little dip switches do. Is you can set the frequency of the SAW filter, and you can set the modulator frequency. So they're quite the units. They're probably worth a few $100, but let's get this one back together. So I've got the cover back on it. Let's connect it up again and test it. We'll connect our RF cable and our video and audio in, and our power. Unit comes on, RF light is on. We have a great picture. And now, for your viewing enjoyment, I'll show you how to program this to any channel. So to program one of these A2020 Agile modulators, these Wavecom, you basically need the programming book, because you're setting a series of dip switches that have to be set to a specific order in order to set the channel. Does that make sense? So right now it's on channel 7, but say for example, I mean, I got the whole manual here. We could read the manual together if you want. Okay. It comes from a company. They are in Saskatoon, Saskatchewan. That's who makes it. Yeah, they just say what they have, right? They have QAM up converters and frequency translators and demodulators and edge devices and Agile CATV modulator. That's what this is. We've got our general overview. Tells you what it can do. And this one here will put out plus 50 dB. So if I crank this thing up and put an antenna on this thing, I would expect that I could probably pick up the signal for a couple hundred feet, at least. It's got a lot of power. And it says RF output is muted if channel synthesizer is not locked. So one of those transistors that I resoldered may have been in the phase lock loop, and it wasn't. It was locked, but it wasn't detecting it was locked, so it kills the power. But I like here it says, the modulator is capable of additional custom channel frequencies not listed in the channel select chart. Consult your supplier if you require a custom channel frequency. Extended VHF channels. The modulator will also produce frequencies in the 7 to 50 megahertz range. These channels are referred to as the extended channels because the harmonics are not internally filtered and the maximum output is plus 50 dB is not guaranteed. And it says an external low-pass filter would be used on those channels. What those channels would be for is, for example, a cable TV operator, say in their van, might want to be able to broadcast live. So they could set up a channel between 7 and 50 megahertz, that's in the reverse, the backhaul channel. That's where when you're using your cable internet, for example, the upload channel is in that lower band. So a cable operator could designate any channel in that 7 to 50 megahertz spectrum, which is below channel 2, and use that as their backhaul channel so that, say, one of their community TV people, they could plug their modulator into any cable outlet and feed it back to the head end. That was what that was designed for. Mostly for cable operators so they could do community TV from remote location. So we've got all these settings, and now we get to the juicy part. We have channel and filter settings. And we've got the NTSC channels. And they'll also be, these are for off-air channels, I believe. No, are these cable? One of these groups is off-air, and the other one is cable. I actually had to go through my chart a bit here to figure this out. Okay, here's our NTSC channels. It's been a while since I programmed one of these. So we got our channels below channel 2, which are the backhaul channels, T-7 to T-13. And then starts with channel 2 all the way up to 6. And then 95, 96, 97, 98, and 99. Those are the ones in the FM broadcast band that most cable operators never ever did use for analog, because back in the analog days they generally had the FM service in there. And then we get into the cable channels. These are the mid-band channels 14 through 22. And then channel 7, which is where this one's set to right now. If I look at the dip switches, they'll be set to that. There are some channels in between 7 and 8 that were available for different offsets, for different harmonic, like HRC or IRC cable systems. And up 10 to 13. Then we go to channel 23. These are cable channels 24 all the way up to channel 59. We flip over the page. These are the cable channels in the super band, and once we get over the page, we'll go right up to channel 78. We'll flip over the page here, channel 79, or 78 there. And then we start out, this is 27, which is UHF channel 27. So now our channels are intermixed. So 27, 28, 29, 30, 31, 32, etc., etc. Let's say I'd like to set this for analog channel 2. So I look up my chart here, and I find that I have to set the filters to 1011, 0111, 1101101, and the channel select to 0111000. So if I just go through and I set the dip switches according to that chart, so 0 is down, 1 is up. So I'm going to set it to 1011. So I go 1011, and then 0111. So 0, 111. Okay, that's got that one set for the first filter, and the second filter is 1101. So 1101. 101. And then 1101 and 1101, same thing. So 1101, 1101. Okay, now if I turn the camera around and see, I'm still set for channel 7. If I turn the camera around and show the screen, the filter is really going to attenuate that signal down because I've now set the filter for the channel 2 filter. I go back over to the modulator and I'm going to set the channel for channel 2. So the channel 2 is 0111000. So 0111000. As soon as I set it, the light goes out for a few seconds. Now it's come back on. The TV has gone to snow. If I go to channel 2, there we go. Now we're on channel 2. That's the beauty of modulator like this, is that you can set this to any channel. So if I wanted to add another channel to my cable system that I've got right now, I could insert this with a splitter and it would be on channel 2. And that would complement the channel 4 modulator that I've already got. I have another identical unit to this which is set to 5 if I desired to use that. I could have a channel 2, a 4, a 5. I have a 7, a 9, and a 12 stereo modulator already set up. So that's the strength to these Agile modulators, is you can tune them anywhere. I generally like to use the low band channels on the cable here, and the reason I like to use the low band channels is because I have an off-air antenna, which the signal from my off-air antenna is amplified and mixed in with the existing cable signals. That way I can pick up the off-air broadcast stations, which are all on UHF. So my digital off-air signals come in off-air. They go through my house cable system. Anything that I want to add, such as security cameras or my DVD player or cable boxes or anything I want to add in standard definition, I can add on these analog modulators and put them on one of the low band channels between 2 and 13. So that's generally why I keep these on the low channels. There, now you know. Hope you enjoyed this look at this Wavecom Agile modulator and the troubleshooting and repair that I did to get this one going. And we'll catch you in the next video. Bye for now.